In this section, we will learn how to compute the ultimate bearing capacity of group piles in saturated clay. To compute the ultimate bearing capacity for group piles in saturated clay, we have to follow the following procedure. First, we determine the ultimate bearing capacity based on the individual pile. By computing the ultimate bearing capacity for single pile, and then multiply the ultimate bearing capacity for single pile by the number of the piles. If the pile have the same dimension, if the piles do not have the same dimension, we have to compute the bearing capacity of every pile, and then get the result of addition of all the bearing capacity of the piles. Take this formula: summation of ultimate bearing capacity equal to N1 multiplied by N2. N1 multiplied by N2 gives us the number of piles. QP plus QS is the ultimate bearing capacity of single pile. QP is the point resistance. QS is the skin friction of the pile, skin friction. Computing QP by the following equation is by the following equation: AP, area of the pile, multiplied by QP. QP, as we learned in the previous lectures, multiplied by N sub C multiplied by end drain cohesion near to the tip of the pile, or at the point of the pile, under the point of the pile. NC equal to 9, and Cu is the end drain cohesion of the clay at the pile tip. QS equal to summation of alpha, and many methods for alpha, P perimeter, Cu end drain cohesion, delta L is the length of the pile at the specified layer. Therefore, the equation, the ultimate bearing capacity of group piles in a clay, can be calculated by this equation: N1 multiplied by N2 multiplied by the summation of QP and QS. QP is 9 multiplied by AP multiplied by end drain cohesion plus summation of alpha perimeter end drain cohesion multiplied by delta L. The efficiency here is assumed equal to 1. Therefore, we just need to calculate the bearing capacity of single pile and multiply it by number of piles. In the second step, we assume that the failure as a block shear failure. Block shear failure. In a block shear failure, we imagine that all the piles in a block will fail, will settle and then fail. In that case, friction will induce around the block of the piles as presented here. This is the shear, which means that the perimeter of the piles is not for one pile, it is for a block of piles. With respect to point resistance, also the area of pile section, not the pile section, it is the area of the block of piles. This is the difference between the two failure criteria. Step 2, determine determine the ultimate capacity by assuming that the piles in a group act as block with dimension LG, length of a group of pile, BG is the width of the group of pile, and L is the length of piles. The skin resistance of a block is skin resistance equal to, as presented here, 2 multiplied by LG plus BG, this is the parameter, multiplied by end-to-end cohesion, multiplied by delta L. With respect to point resistance, end-to-end cohesion multiplied by NC multiplied by the area LG by AG. This is the skin friction. And this is the point resistance, LG multiplied by BG, end-to-end cohesion multiplied by NC star. Obtain the value of bearing capacity NC star from the following figure. In this figure, with the value of L is the length of the pile, over BG is the width of the group. It is the shortest dimension of the pile group, L over BG. If L over BG, for example, equal to 2, then we have 4 curves. Every curve represents case of LG over BG equal to 1 square block, or 2 or 3, or theoretically infinity. Then to the left you can get the value of NC. L over BG, if it is greater than 4 for square block, it nearly approximately equal to 9. If L over BG greater than 4 at any point here, NC will be equal to 9. The equation that will be used to compute the ultimate bearing capacity based on the block shear failure is this equation. This is the equation 2. LG multiplied by BG multiplied by end-to-end cohesion multiplied by NC plus summation 2 LG plus BG is the parameter, end-to-end cohesion, delta L. In this book, he assumes alpha equal to 1. Therefore, to compute the ultimate bearing capacity, we have to solve for 2 cases. First, compute the ultimate bearing capacity based on the bearing capacity of individual pile. Second, compute the ultimate bearing capacity based on the block shear failure. And in the step 3, choose the lower value of the ultimate bearing capacity. Now let us take the following example to explain how to compute the ultimate bearing capacity for pile group in saturated clay. In this example, the section of a 4 by 5 group pile in a layered saturated clay is shown in figure below. The piles are square in cross section 300 by 300. The center to center spacing D of the pile is 900 millimeter. Determine the allowable load bearing capacity of the pile group. Use factor of safety equal to 4. Note that the ground water table coincides with the ground surface. The pile are shown in this figure. كما تلاحظون بالنسبة لهذه البايلز السويل تمر في السويل بروفايل. هذا السويل يتكون من طبقات، 3 طبقات. الطبقة الأولى سمك الطبقة الأولى 4 متر، سمك الطبقة الثانية 6 متر، سمك الطبقة الثالثة 10 متر. Underend cohesion for the first layer equal to 50, gamma saturated equal to 70. For the second layer, underend cohesion equal to 80, gamma saturated equal to 18 kilonewton per meter cubic. And for the third layer, underend cohesion equal to 120 kilonewton per meter square, and gamma saturated equal to 19 kilonewton per meter cube. Use the previous procedure to compute the ultimate bearing capacity. In the first step, we have to compute the ultimate bearing capacity based on the bearing capacity of individual pile, and then multiply the bearing capacity by the number of the piles. Number of the piles here is 4 multiplied by 5 equal to 20. N1 by N2 equal to 20. Number of piles in this group equal to 20 piles. Now to compute the ultimate bearing capacity for this group of piles, first compute the ultimate bearing capacity by the component point resistance. This is point resistance, AP, area of the pile, multiplied by 9, which is the NC, the bearing capacity factor, multiplied by the end-drain cohesion at the tip of the pile, plus summation of the skin friction for the first layer, plus skin friction for the second layer, plus skin friction alpha 3 multiplied by end-drain cohesion 3 for the third layer, multiplied by L3, the thickness of the third layer. نحتاج إلى أن نستخرج الألفا لكل طبقة من هذه الطبقات بالنسبة للسكين فريكشن. لو استخدمنا الطريقة الأولى التي تعتمد على التيبل اللي هو باي ترزاقي بيك آن مزري اللي بالطبعة اللي بال96 واللي يستخدمها داز في كتابه، تعتمد على الاندريند كوهجن اوفر بي اي atmospheric pressure. اندريند كوهجن بالنسبة للطبقة الأولى 50 كيلونيوتن، نقسمها على 100 اللي هي atmospheric pressure، نحصل على 0.5. الآن ندخل إلى الجدول 10 variation of alpha، لدينا 0.5 تقع between 0.4 and 0.6، between alpha between 0.74 and 0.62. by using interpolation يمكن أن نحصل على قيمة الألفا equal to 0.68. يعني الفرق من 8 4 12 يقسم على 2 6، then 0.62 plus 6 0.06 equal to 0.68. إذن ألفا 1 equal to 0.68 بالنسبة للألفا بالنسبة للطبقة الأولى. بالنسبة للطبقة الثانية أيضا الأندريند كوهجن equal to 80 divided by the atmospheric pressure equal to 0.8. 0.8 according to table 910 0.8 gives us alpha equal to 0.54. This is alpha 2 equal to 0.54. For the third layer, cohesion, underend cohesion equal to 120 kilonewton per meter square over 100, the atmospheric pressure equal to 1.2. Use the table 910 1.2 gives us alpha equal to 0.42. Now replace alpha 1, alpha 2, alpha 3 in the equation of skin friction. Summation of ultimate bearing capacity equal to plus alpha 9 end-to-end cohesion AP plus alpha 1 end-to-end cohesion parameter delta L plus alpha 2 end-to-end cohesion C end-to-end cohesion for the second layer multiplied by parameter multiplied by delta L for the second layer plus alpha 3 multiplied by end-to-end cohesion for the third layer multiplied by parameter multiplied by delta L for the third layer. Now N1 equal to 4, the number of the pile, and N2 in the horizontal direction 1 2 3 4, N1 equal to 4 piles, N2 equal to 5 piles, 1 2 3 4 5 piles. 4 multiplied by 5 gives us the number of piles in the group. Number of piles in the group equal to 20 piles. Now 9 equal is the NC, is the bearing capacity, is the bearing capacity factor, equal to 9, bearing capacity factor for pile in clay, NC equal to 9. AP, the area of pile, equal to 0.3 multiplied by 0.3. The dimension of the pile is 300, the width, and 300 the length, or 0.3 by 0.3 in meter. 0.3 square, the area of the pile, multiplied by end-to-end cohesion. Here the end-to-end cohesion, we have to choose the value at the tip of the pile. The value of the tip of the pile end-to-end cohesion equal to 100. At this level, end-to-end cohesion equal to 120 kilonewton per meter square. This layer we continue. The third layer continue with end-to-end cohesion equal to 120 kilonewton per meter square. Plus skin friction for the first layer. Skin friction for the first layer alpha 1.68 multiplied by end-to-end cohesion for the first layer, end-to-end cohesion equal to 50, multiplied by parameter for the first layer, parameter for the pile in the first layer 4 multiplied by 0.3, or 0.3 plus 0.3 plus 0.3 plus 0.3, multiplied by the thickness of the layer. Thickness of the layer is 4 meter. Thickness of the layers multiplied by the parameter gives us the surface area. For the second layer, alpha 2 equal to 0.54 multiplied by the end-to-end cohesion for the second layer. For the second layer, end-to-end cohesion equal to 80 multiplied by 4 multiplied by 3 is the parameter multiplied by the thickness of the layer. Thickness of the second layer equal to 6 plus 0.42 is alpha 3, alpha for the pile in the third layer multiplied by the end-to-end cohesion. End-to-end cohesion for the third layer equal to 120 multiplied by 4 multiplied by 3 is the parameter multiplied by the length of the pile at the third layer, or the thickness of the third layer equal to 10 meter. We get 97 is the QP, QS1, QS2, QS3. The total QS equal to 1079 and the QP equal to 97.2. QS plus QB gives us Q ultimate for single pile. Now multiply Q ultimate of the single pile by, multiply it by 20, the number of piles, results the ultimate bearing capacity of the group of piles, which equal to 23,524 kilonewton. This is the ultimate bearing capacity of pile group based on the individual pile. We compute the ultimate bearing capacity for single pile and then multiply the ultimate bearing capacity of single pile by the number of piles. In step 2, we compute the ultimate bearing capacity based on the block shear failure. We consider all the piles as a block and compute the parameter of the block and the area of the block. For piles acting as a group, we call it block shear failure according to Terzaghi in 1967. LG is the length of the group of pile. Length of the group of pile equal to 4 multiplied by 0.9. Since from center to center of pile to center of pile, the distance S equal to 900 millimeter, which is equal to 0.9 meter. 0.9 meter, and this distance 0.9 meter, this distance 0.9 meter, this distance 0.9 meter, 0.9 meter multiplied by 4. We get the distance from the center of the outer pile to the center of the outer pile. Add to this value half dimension of pile here and half dimension of pile here. If the width of the pile equal to 0.3, width of the pile is 0.3, so here 0.15 and here 0.15. 0.15 plus 0.1 equal to 0.3. Therefore, LG equal to 4 multiplied by 0.9 plus 0.3. 4 here is the n minus 1. N1 minus 1. N1 is number of piles. 1, 2, 3, 4, 5. 5 minus 1 equal to 3.9 meter. With respect to BG, the width of a group of piles, also N2 minus 1 multiplied by S, the distance between piles from center to center, plus diameter of one pile, equal to 4 minus 1, 1, 2, 3, 4, 4 piles. 4 minus 1 multiplied by S. S is the distance from center to center, plus D is the diameter of pile, equal to 0.3. Therefore, BG equal to 3 meter. The dimensions of the group of pile equal to 3.9 by 3. The distance here 3, and the length of the pile equal to 3.9 meter. always BG is the shortest dimension. Always is the shortest dimension. We need LG over BG, divide 3.9 over 3 equal to 1.3, and L, the length of the pile, 20 over 3 equal to 6.67. We need to these values and include with these values to this figure for L over BG equal to 6.67 greater than 5, and LG over BG equal to 1.3, between 1 and 2, this curve between 1 and 2, and also behave like other curves at 3 or 4, gives us constant result, and continue here. Project this value 6.67 with this value, we get NC equal to 8.75. 8.75. Now substitute the bearing capacity factor in this equation. LG is the length of a group of pile 3.9, BG equal to 3, and drain cohesion with respect to point resistance equal to 120 multiplied by 8.75, the bearing capacity factor. What is the difference between point resistance computed in this method, in this criteria, with the previous criteria? The differences are NC here equal to 8.75, while in the previous method equal to 9. LGBG equal to 3.9 multiplied by 3, while the previous method equal to 0.3 multiplied by 0.3. Now to compute the skin friction by this method, 2 multiplied by 3.9 plus 3, it is the perimeter of the block, multiplied by end-to-end cohesion for the first layer by the thickness of the first layer, plus end-to-end cohesion for the second layer multiplied by the length of the second layer, end-to-end cohesion for the third layer multiplied by the thickness of the pile and the third layer. Then you get the point resistance equal to 12,285, and the QS equals to 2,760, 6,624, 16,560, equal to 25,944. Add a QS to QP gives the ultimate bearing capacity 38,229 kilonewton. This value is the ultimate bearing capacity of a group of piles in clays in the second step, in the second method, based on the block shear failure. Compare this value with the value of the ultimate bearing capacity computed in the first step. In the first step, we get the ultimate bearing capacity equal to 23,524. Since this value is lower than the value of the ultimate bearing capacity, we select it. We choose the ultimate bearing capacity equal to, for the pile group, equal to 23,524 according to step 3 in the procedure. Therefore, the summation of ultimate bearing capacity, or the ultimate bearing capacity, the total ultimate bearing capacity of piles, or the ultimate bearing capacity of pile group, equal to 23,524 kilonewton. Please note that in the second case, in the second step, we don't need to multiply the ultimate bearing capacity by the number of piles, since we assume that all the piles behave as a block. Now, to get the allowable bearing capacity, divide the ultimate bearing capacity by the factor of safety 4. You get the following value: 5,881 kilonewton, or 588 in tons. Let us take another example. Example 2. The section of a 3x3 group pile in a layer saturated clay is shown in figure below. This figure shows the profile of the soil and the group pile or pile group in this soil. The piles are square in cross section, 356 mm by 356 mm. The center to center spacing D of the pile equal to 889 mm. D, or sometimes they call it S, is the distance between piles from center to center. Determine the allowable load bearing capacity of the pile group. Use factor of safety equal to 4. Note that the groundwater table coincides with the ground surface. The ground water table coincides with the ground surface. There are two layers. The first layer is a clay layer with underend cohesion equal to 50.3 kilonewton per meter and gamma saturation equal to 70.6 kilonewton per meter cube. The thickness of the first layer is 4.57 meter, and the second layer, clay, underend cohesion equal to 85, gamma saturation equal to 19.09. The distance from center to center equal to 889. This example was presented by Daz in his book in the 9th edition. To solve this question and to get the ultimate bearing capacity of pile group, we use the previous procedure. First, we compute the ultimate bearing capacity for single pile, then multiply it by the number of piles. Use this equation: summation of ultimate bearing capacity QP plus QS. QP equal to 9. 9 is the bearing capacity factor, and C, multiplied by area of the point of the pile section, multiplied by underend cohesion at the tip of the pile, plus QS. QS, since we have two layers, QS for the first layer plus QS for the second layer. We have to compute alpha 1, alpha 2. Use the method presented by the book of Terzaghi, Peck, and Mesri in 96, and presented by book of Daz. Underend cohesion over PA atmospheric pressure. Underend cohesion 50.3 over 100 equal to 0.525. Use the table below. Use this table, 0.52. Using interpolation, you get the following value of alpha equal to 0.61. Underend cohesion for the second layer, 85.1 over 100 equal to 0.85. use the same table for 0.85 here. 0.85, it is between 0.8 and 0.1, and alpha between 0.54 and 0.48. We get the following value for alpha equal to 0.51. Now replace these two values in the equation. Now 3 is the n1 and 4 is the n2. 3 multiplied by 4 gives us 12. 12 is the number of piles in the group. 9 is the NC multiplied by the area of the piles, individual area of the pile, individual pile, multiplied by end-to-end cohesion at the tip of the pile. Here at the tip of the pile, the end-to-end cohesion is 85.1 kilonewton per meter square, plus alpha 1 multiplied by parameter 4 multiplied by 0.356 multiplied by end-to-end cohesion, and the thickness of the first layer 4.57. This is the thickness of the first layer, plus 0.51 alpha 2 multiplied by parameter multiplied by end-to-end cohesion for the second layer multiplied by the length of the second layer. We get for 14,011 kilonewton, the ultimate bearing capacity based on the bearing capacity bearing capacity of individual pile and multiplied by the number of piles in a group. In the second case, we have step 2. Step 2, compute the ultimate bearing capacity based on a block shear failure. We have to compute first LG and BG, length of the group and width of the group. Length of the group, since we have 3 by 4 piles, 4 piles and 4 by 3. First distance, second distance, third distance, therefore 3, or 4 minus 1 multiplied by D or S, the distance from pile to pile, from center to center, plus diameter of the pile, gives us 3.023 meter. Width of the group of pile, here the draw is very difficult, 2 n minus 1, 3 minus 1 multiplied by distance from center to center plus diameter of the pile gives us the result. Now LG over BG, LG length of the pile group over width of the pile group gives us 1.42, and L length of the pile over BG 18.29 gives us 8.57. Now include this figure with this value 8.57. 8.57. It is greater than 5 here. 5, 6, 7, 8.7. And since L over B equal to 1.42, so we have to draw this curve between 1 and 2, which is continue, and then intersect with this curve, gives us approximately the same value that obtained in the previous example. Therefore NC also equal to 8.5, approximately equal to 8.75. Now replace this value in the equation of block shear failure. LG multiplied by BG is the area of the block section, multiplied by end-to-end cohesion multiplied by NC, 3.023 LG multiplied by BG multiplied by the end-to-end cohesion multiplied by NC plus QS 2 multiplied by 3.023 plus 2.143. This is the perimeter of the block. End-to-end cohesion multiplied by the thickness of the first layer, end-to-end cohesion of the second layer multiplied by the thickness of the second layer gives us 19,217 kilonewton. Compare this value 19 with this value 14. We choose the lower value, which is the first one, 14. We can see that in these two examples, in the two previous examples, the lower value is obtained from the first step, from the method that's based on the bearing capacity of individual piles. We can get the apparent efficiency by dividing the value of the ultimate bearing capacity computed by block shear failure over the ultimate bearing capacity computed based on pile individual 14. We can get the apparent efficiency. Now hence ultimate bearing capacity equal to 14,011 kilonewton. Divide this value by factor of safety, gives us 3,503 kilonewton is the allowable bearing capacity of group of piles.